Today we're out here outside of Ephrata, Washington, and we're going to take a soil sample on an upcoming potato crop. I'm Brady Stover. My passion is agriculture, agronomy, and sharing my experiences. Join me on my journey through the Pacific Northwest. So what soil sampling is we go out there and we are looking to find what nutrients are in the soil profile where the root zone of the particular crop is going to be planted. So what that tells us is what nutrients will be available to that crop that's already in this field or potentially available to that crop. And then we will take that soil rec and see, okay, if we have X number of pounds of nitrogen or potassium, but our crop is going to need 200 more pounds, then we know that we need to, during the growing season, apply the difference to that crop. And so what the soil sample allows us to do is find that foundation of nutrients that we have available and allows us to make the fertilizer recommendation moving forward. So what is a soil probe? A soil probe is a tool used to take a core sample of the soil, and you want a good slick surface. And this one, because it's an annual crop in potatoes, we have a good 12-inch profile here. If you're doing something like a dryland wheat, you're going to want a much larger probe, possibly 3 feet, because that is where the root zone of that crop goes. But potatoes and some of these annual crops that we're sampling for here only go about 1 foot. So that's why you want to match your core length with your root zone. It has a removable tip because we are going into coarse texture soils many times, and these will wear down. So a good exchangeable tip is quite necessary. And I like the probe that I can actually take apart at the end of the day and pack up in my pickup. And it does not take much room. It goes back into a case. I don't get dirt all over my pickup, and stores very nicely and safely. And when I'm just going field to field, or I'm going to be using it a lot, what I like to do is have my other storage unit. Seem to use these quite often. So I like to keep everything put together. So when coming out to take a soil sample, there are many different methods, and we'll start with a whole field composite as the first example. And so if we took the whole circle that we are sampling, we would want a randomized sample. So what I really like to do when I get to the field is go to the middle on the end and make a diamond pattern, and taking about 60 cores for the whole circle itself. And in those 60 cores, we will fill up our bucket, we will mix that dirt all together, and that will give us a composite for the entire field. Now, another way to do this, the second way, would be to create this field into different zones. And that is key to do if you have varying topography or if you have different soil types and pHs within that unit. So the way that we would do that is we would split this circle into 4 pieces, 25% in each piece, and then we would do a W within that quadrant, and then we will go to the next one and do another W. That gets us all the way to the edge. That gets us into the middle of the field, and we will do about 30 cores per section on that quadrant, on each quadrant. And then the third way is a much more intense way, and this is done when you also, for example, a potato crop, when you have a high input such as fumigant. We do grid sampling. Grid samples can be anywhere from 1 acres to 5 acres, depending on your desire. It can be a little bit bigger, but much smaller than the zone sampling. But our grids, what I've done in the past is every 1 acre, we take a soil sample, and what I do is I drive to the middle of that acre and with my Gator 4-wheeler or pickup, and then I take 12 core samples around that vehicle that I'm using and put that into a bucket, and we do that on every single grid. So coming out of a 120 acre circle, we would have roughly 120 soil samples. And from that, we would get our number from each point where we took the sample, and then an average between the points, and that allows us to create variable rate mapping systems for the desired input. So we've decided to do a composite sample on this field, and in this pattern, one thing that I want to make sure that I'm cautious of is that I'm getting a good representation of the whole field. So what I mean by that is when I'm making my W pattern through this section, I want to make sure that I am not taking too many samples on, I don't know if you can see on the camera, but over there we have about 30-foot elevation, and we have a low spot right ahead of us, and we have another knoll closest to us. And so I want to make sure that I do get a sample from each section, but I'm not taking too many samples from on top of the knolls without representing the bottom, and vice versa. I don't want too many in the bottom without representing the top, because the way that nutrients move with moisture, you could have a higher concentration of some nutrients in those low spots than the high spots. And so you want to make sure that you're having a good fertility program to compensate for both issues that may occur. Well, we have our first issue here. Soil sampling seems to be pretty straightforward, but as you can see, when we talked about needing to get down to that whole 1 foot profile where those roots are going to be, we realized that we're getting out here and we still have frost or some sort of hard pan down below. And because of the weather, temperature, and I know the way that this field was tilled, I know that that's because of the frost. So in this case, we have a couple of options. I could go back and get a soil probe that has a foot peg on it, that maybe I could get more leverage and break through and get more soil profile in here. The next one would be go get my hammer and try to hammer that down in and get the remaining soil profile included in this. There are some tools out there, and this is used a lot in the dry land and hard pan. They have drills where they are specifically meant to drill and get a core using mechanical tools. Or another option, if we were in a really big bind with time and we needed a soil sample, we could send this same sample in, but I need to make sure that I take a measurement of how large the sample is consistently. So in this case, it's going to be about that 8 inches, and I would go get a measuring tape to be precise, and I would write that down on my soil sample so that they know how much of the soil profile I was using, because the concentration of nutrients to the depth that you went changes the equation. So we're going to have a certain amount of nutrients in the top 8 inches. We can't say that it was 12 because we don't have that much soil in that. So our percentage is going to be different. So we need to calculate off of how much we've actually taken. So a couple of tricks I've learned along the way while pulling these grid samples, getting to do 1,500 acres of 1 acre grid samples, I've learned a couple of things through trial and error. The first thing is I like to get a bucket that is the same width as the probe, so that I'm not having to work and try to finagle on how to get the dirt in. It's quick and seamless. You put your probe in, you get your soil sample. I like to twist one time to free up the core so that when you pull it up, it stays all compact and nicely in there. If you don't do that, sometimes when you pull it up, it likes to flake out the front and you lose your sample. This is quite wet soil right now and a bit sticky. So again, the width of the bucket, nice, easy, 1-2 tamp. So now that we've walked our design for our composite soil sample, although it kind of got mixed up, this soil, as we tamped it in, to make sure that we're getting a random sample, we're going to go ahead and mix everything up. We want to flip everything. We want to make sure that all of the soil has mixed within itself, because when it goes to the lab, they're actually going to do the same, and they're only going to take a couple spoonfuls out of this to run it through their machines. So we want to get it as random as we can and make sure none of those cores are stuck together and we're only getting a representation of one spot. So here on the soil bag, it's asking our depth. So we'll revisit what we talked about earlier, and we were only able to get samples to about here, and we took that measurement, and that was 8.5 inches. So on the depth, so that we get the proportions right on how much we're sampling, we're going to put 8.5 inches. Crop for recommendation, because we know that the crop uptake for each, or the uptake for each crop is different. We're going to put potatoes because the recommendation will change because of the amount of nutrients that crop needs to grow. And we will now mix one more time for good measure. And this is very wet soil, so you can see that it is clumping quite a bit. And we will work on getting all of this soil into this bag. So now that we've got our bag filled out and we're ready to take our sample to the lab, we need to tell them what test we want. And as you can see, we have test 1 through 9 with a couple of options on 9. And for myself, the very minimum when working with crops would be a number 4. That's going to give us our nitrates in the soil. And again, that's nitrates because that is what is actually plant available. And then our potassium, our phosphorus, and some of these other nutrients. And that is for a general crop. But a more intense crop such as potatoes, I am going to do at least a number 7 sample, and that is because this crop, along with having its micros and secondaries and understanding the pH, it is a crop that relies heavily on calcium, magnesium, and these micronutrients such as manganese and copper. So we want to understand what's in the field already and what needs to be applied in order to best fit this crop. Please like, subscribe, and share for more agronomic content. Uh-oh, that's a water hazard.